Are you curious about how data scientists predict stock prices? In this video, we'll explore how time series analysis can help forecast future stock movements using real market data. Welcome to the world of stock price prediction using time series, a project that combines finance, programming, and machine learning to make intelligent forecasts. Objective. The goal is to predict future stock prices based on historical stock price data using machine learning algorithms, particularly for time series forecasting. Problem. Stock market data is volatile and fluctuates due to various factors. Accurate stock price predictions can help traders make better investment decisions. Solution. Develop a system that leverages historical stock prices to forecast future prices using time series models like ARIMA, LSTM, etc. Time series models. Autoregressive integrated moving average. Model purpose. It predicts future stock prices based on past price patterns and trends. Steps. Differencing to make the time series stationary. Autoregression, using past observations to predict future values. Moving average, using past forecast errors to make predictions. LSTM, long short-term memory. Model purpose, a deep learning model designed for sequential data, particularly for time series forecasting. Steps. Use a sliding window approach to train on the historical data. Apply the LSTM network to capture long-term dependencies in the stock data. Predict future prices based on the patterns learned. Architectural design. Client-side, front-end, a web-based interface where users can input stock symbols and view predictions. This can be built using HTML, CSS, JavaScript, or frameworks like React.js. Server-side, backend Python Flask/Django-based API that processes the request, fetches data, applies time series models, and returns predictions. Database, optional database, example, MySQL, SQLite, PostgreSQL to store past predictions, model metadata, and stock data for future retrieval. Machine learning layer, models like ARIMA and LSTM that take historical data and predict future prices. Activity diagram. Here's an activity diagram for the process where a user provides a stock ticker symbol as input, and the system retrieves, processes, and displays stock data using time series analysis. 1. User inputs a stock ticker symbol. 2. The system retrieves historical stock data from an external API, example, AlphaVantage. 3. The system pre-processes the data. Pre-processing data. Action. The system pre-processes the data, example, handling missing values, normalization. Decision. Ensure the data is in a format suitable for applying machine learning models. Apply machine learning model. Action. The system applies a model, example, ARIMA, LSTM, to the pre-processed data to predict future stock prices. Industry Standard Solution Overview. To develop stock price prediction web application using Flask, MySQL, and the yFinance API according to industry standards, here's a professional approach incorporating modularity, scalability, and responsive UI design. Backend. Python, Flask as the backend framework. MySQL for storing stock-related data. Use yFinance API to fetch stock data. Implement RESTful API for seamless communication. Frontend, HTML5, CSS3, using Bootstrap for responsive design, and JavaScript, Ajax. Responsive, interactive design for a seamless user experience. Implement client-side validation. Architecture, Model View Controller, MVC, Structure. Modular code with reusable components, example, header, footer, templates. Separation of concerns for data fetching, processing, and presentation. Advanced features. Autocomplete for stock symbols with Ajax. Date picker for selecting start and end dates. Frequency selector, daily, weekly, monthly. Error handling for API failures. Visualization for stock predictions, example, using Matplotlib or Plotly. 1. Client-side, front-end, a web-based interface where users can input stock symbols and view predictions. This can be built using HTML, CSS, JavaScript, or frameworks like React.js. The login interface for the user's an admin or user's role in the system. New user can register using the registration form. The application is implemented as follows. Web client. Clients interacts using the web interface. Server component. It is implemented as a RESTful application programming interface to provide services to the web client. Here is the admin login. The admin maintains the stock symbols that can be searched by registered users. The admin also approves or disapproves and deletes the user. Admin can now add new stock symbol in the system. The stock data is stored successfully in the system. Relational database management system is used as database to store and maintain the data. Here is the users table to store and maintain the data of the registered users. This module is used by the administrator to manage the registered users. Admin can now log out from the system. Registered and user approved by admin can now log into the system using login credentials. This is the user interface to interact with the system. The user can either search for new stock price predictions or view the history of search. Autocomplete for stock symbols with Ajax is used to fetch the stock symbol from the database. Date picker for selecting start and end dates. Frequency selector, daily, weekly, monthly. Also the number of days for which prediction is required. Now click on the Fetch Stock Data button. Here is the fetch date for the selected data for the selected input parameters. A graph indicates the stock data. Let's apply machine learning to predict future stock prices. These are the predicted values. This is my SQL database to maintain the data of the system. Built using Python, with tools like yFinance for fetching stock data, Pandas for data handling, and Matplotlib or Plotly for visualization. This project also features a user-friendly web interface. Whether you're a student, developer, or investor, this project demonstrates the real-world application of data science in finance, and how AI can be a powerful tool in decision-making. Stay tuned as we break down each part of the project, step by step. Don't forget to like, share, and subscribe for more tech-based learning. Thanks for watching the video. Please like, share, and subscribe to my channel. Next videos will discuss the complete development of client and server side. Thanks once again, guys. See you soon.